Hi everyone. Today I am going to solve previous year's questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. మనం ఇప్పుడు first question చూద్దాం. In a potentiometer experiment, it is found that no current passes through the galvanometer when the terminals of the cell are connected across 52 centimeters of the potentiometer wire. If the cell is shunted by a resistance of 5 ohm, a balance is found when the cell is connected across 40 centimeters of the wire. Find the internal resistance of the cell. అంటే మనకి ఏమి ఇచ్చారు? He gave balance length for the cell case as 52 centimeters. He gave balance length for the shunted cell case as 40 centimeters. He gave shunt resistance value as how much? 5 ohm. Right. He is asking us to find internal resistance of the cell. Right. That means the potentiometer circuit for the cell case can be drawn like this. You can see. Yeah. It consists of long wire AB of uniform cross section in series with battery E0 and rheostat R0 here, which is kept at suitable position so that a constant current I0 flows through the main circuit of the potentiometer, which is ABCDA. Right. In the sub-circuit, cell is connected in series with the galvanometer in such a way that moving contact J is kept in contact with wire AB. Let us say cell e.m.f is A, its internal resistance is R. Right. Let us say balance point for this case is at position 1. So that is the thing. Manaku balance dagara em avutadi? Cell e.m.f becomes equal to potential difference between junction A and moving contact position 1. So that means E becomes equal to VA1, which is equal to I0 into RA1 from Ohm's law, where I0 is main circuit current, RA1 is resistance of the wire between junction and moving contact position 1. So which is equal to rho LA1 by A dash, where rho is resistivity of the wire, LA1 is length of the wire between A and 1, which is nothing but balance length. A dash is its area of cross section. So here I0, rho and A dash are constants. Let us say I0 rho by A dash is equal to constant A. Right. So we got finally E is equal to A into LA1. So let us say this is equation 1. Right. Let us consider second case in which a resistance R is connected across the cell. Here you can see the circuit is closed. Let us say I dash is the current flowing through it. Right. Let us apply KVL to get I dash. So E minus I dash R minus I dash R smaller becomes 0. Right. So we are going to get I dash as E by R plus R. Let us say potential difference across the resistance R is VR, which is equal to I dash into R from Ohm's law. So which is equal to E by R plus R into R. Right. Let us say balance point for this case is at position 1 dash. Right. Yeah. మనకు బ్యాలెన్స్ దగ్గర ఏమవుతుంది? పొటెన్షియల్ డిఫరెన్స్ across the cell becomes equal to potential difference across the balance length. What is the potential difference across the cell? Which is nothing but potential difference across the resistance R. So that means VR becomes equal to VA 1 dash, right, which is equal to I0 RA 1 dash. So which is equal to I0 rho LA 1 dash by A dash. Here LA 1 dash is balance length for this case. So we assign I0 rho by A dash as A. Right. So this becomes equal to A into LA1 dash. Yeah. So but VR we got as ER by R plus R. So ER by R plus R is equal to A into LA1 dash. Let us take it as equation 2. So when we take ratio of equation 1 by 2, what we are going to get? Yeah. So here E gets cancelled. A gets cancelled. We are going to get R plus R by R is equal to LA1 by LA1 dash. Right. So that is equal to, so 1 plus R by R is equal to LA1 by LA1 dash. Right. So when we take one that side and simplify, we are going to get R by R is equal to LA1 minus LA1 dash by LA1 dash. So when we take R that side, so it becomes multiplication. So when we substitute on these values, which are nothing but 5, 52, 40, we are going to get right 4 3 ja 4 10 ja 15 by 10. So that means 1.5. మనకి ఏ ఆప్షన్ సాటిస్ఫై చేస్తుంది ఏ సో ఏ ఇస్ ద ఆన్సర్ రైట్ లెట్ us move to next question yeah in a potentiometer experiment the balancing with a cell is at a length 240 centimeters and shunting the cell with a resistance of 2 ohm the balance length becomes 120 centimeters the internal resistance of the cell is right అంటే ఏమి ఇచ్చారు మనకి ఇక్కడ the balancing length for the cell case he gave us how much 240 centimeters. Shunted cell case he gave us 120 centimeters. He gave shunt resistance value as 2 ohm. He is asking us to find internal resistance of the cell. Right. మనకు సెల్ కేస్ లో బ్యాలెన్స్ దగ్గర ఏమవుతుంది సెల్ EMF becomes equal to potential difference across the balance length for that case. Right. Which is equal to A into LA1. Yeah. So which we obtained in the previous question. Similarly, for shunted cell case, balance దగ్గర ఏమవుతుంది potential difference across the cell becomes equal to potential difference across the balance length for that case. So which is equal to ER by R plus R is equal to A into LA1 dash. Right. When we take a ratio of 1 by 2 and simplify, what we are going to get? R is equal to R into LA1 minus LA1 dash by LA1 dash. Here you can observe the balance length for the second case is half of the first case. So that is mean LA1 dash is half of LA1. So when we substitute what we are going to get, so this we are going to get as LA1 by 2. So this and this cancels. So we get R is equal to R. That means when balance length becomes half, internal resistance value becomes equal to shunt resistance value, which is nothing but 2 ohm. So which option satisfies B? So this is the answer. Let us move to next question. The balancing length for the cell is 560 centimeters in a potentiometer experiment. When an external resistance of 10 ohm is connected in parallel to the cell, the balancing length changes by 60 centimeters. If the internal resistance of the cell is n by 10 ohm, where n is an integer, then value of n is right. అంటే ఇందులో ఏమి ఇచ్చారు మనకు he gave balance length for the cell case as 560 centimeters. He gave shunt resistance value as 10 ohm. He gave change in balance length for the shunted cell case as 60 centimeters. He gave internal resistance value n by 10 ohm. He is asking us to find value of n. Right. Yeah. మనకు సెల్ కేస్ లో బ్యాలెన్స్ దగ్గర ఏమవుతుంది సెల్ EMF becomes equal to potential difference across the balance length, which is nothing but A into LA1. Right. Similarly, for shunted cell case, potential difference across the cell becomes equal to potential difference across the balance length for that case. So right. So ER by R plus R, which is nothing but E into R plus R. R by R plus R is equal to A into LA1 dash. Right. This can be written as E into 1. E into 1 is E only. Here when we compare this 1 and R by R plus R. R by R plus R is going to be little less than 1. That means when we compare these two equations, LA1 dash is going to be lesser than LA1. Okay. He gave change as 60 centimeters. That means LA1 dash is going to be 60 centimeters less than LA1. So that means LA1 dash is equal to how much? 500 centimeters. So that is it. Right. So when we take ratio of these two equations and simplify, we are going to get expression is R is equal to R into LA1 minus LA1 dash by LA1 dash. So he gave R value as 10, LA1 as 560, LA1 dash as 500. Here you can see 560 minus 560. Right. So 5 1 is 0.2. So R value he gave n by 10. So when we take 10 that side, 1.2 into 10, 12. So 12 is the answer. Right. Let us move to next question. A potentiometer PQ is set up to compare two resistance as shown in the figure. The ammeter in the circuit reads 1 ampere when two-way key K3 is open. The balance point is at length L1 centimeter from P when two-way key K3 is plugged between 2 and 1, while the balance point is at length L2 centimeter from P when key K3 is plugged between 3 and 1. The ratio of two resistances R1 and R1 by RP is found to be right. అంటే మనకి ఏమి ఇచ్చారు? When key K3 is open, he gave current flowing through the circuit, that is upper circuit is 1 ampere, right? When key K3 is plugged between 2 and 1, he gave balance length as L1 centimeter. When it is plugged between 3 and 1, he gave balance length as L2 centimeters. He is asking us to find R1 by R2, right? When key K3 is plugged between 2 and 1, what happens? Resistance R1 gets connected to the potentiometer. That means in this case potentiometer measures potential difference across the resistance R1, right? At balance దగ్గర ఏమవుతుంది? Potential difference across resistance R1 becomes equal to potential difference across the balance length, which is nothing but L1. So VR1 becomes equal to VL1. That's all. VR1 is equal to IR. I is nothing but 1 into R1. VL1 is A into L1. So this is the first case. In the second case, key K3 is plugged between 3 and 1. Now here you can see R1 and R2 both gets connected to the potentiometer. That means in this case potentiometer measures potential difference across the resistance R1 and R2. Okay, right. మన బ్యాలెన్స్ దగ్గర ఏమవుతుంది? At balance potential difference across the R1 and R2 becomes equal to potential difference across the balance length. For that case, that is nothing but L2. So VR1 plus R2 becomes equal to VL2. So from Ohm's law, this becomes equal to 1 into R1 plus R2. So this is A into L2. So when we take equation 2 by equation 1, what we are going to get? R1 plus R2 by R1 is equal to, right, L2 by L1. So 1 plus R2 by R1 is equal to, we are going to get L2 by L1, same. So when we take 1 that side, R2 by R1 is equal to, so L2 by L1 minus 1, which is nothing but L2 minus L1 by L1. That means R1 by R2 is equal to how much? Reverse of this. L1 by L2 minus L1. Which option satisfies? L1 by L2 minus L1. So D. So D is the answer, right? Let us move to next question. It is preferable to measure the e.m.f of a cell by potentiometer than by voltmeter because of the following possible reasons. Yeah, first one. In case of potentiometer, no current flows through the cell, right? మనకి ఏం తెలుసు? At the time of measurement, current drawn by the cell is 0. So that means first one is correct. The length of the potentiometer allows greater precision. This is also correct. Measurement by the potentiometer is quicker. That we cannot say. So right. The sensitivity of the galvanometer when using a potentiometer is not relevant. No, it is relevant. This is because greater is the sensitivity of the galvanometer, higher is the precision of the measurement. So this is wrong. 1 and 2 are correct. Which option satisfies? C. C is the answer. Right. So today I solved 5 previous years questions. Thank you.